The Manual on Uniform Traffic Control Devices, or MUTCD, now requires the continued use of a method designed to maintain pavement markings at or above specific minimum retroreflectivity levels. The MUTCD recommends using one or more of 5 methods described in detail in the FHWA publication titled Methods for Maintaining Pavement Marking Retroreflectivity, linked below and referred to as the Methods Report throughout this video. This video will introduce you to the 2 nighttime visual inspection methods. Links are provided in the description below to videos related to this topic and other methods. Like the other methods, the first step for both nighttime visual inspection methods is to decide which roads and markings your agency will include in its method. There are some key differences between the 2 visual inspection methods because one compares markings near the minimum levels to those being inspected, while the other simulates the primary factors in the research that develop the minimum levels. The calibrated markings method requires the inspector to view a set of markings with known retroreflectivity levels at or above the MUTCD minimum levels each night before the inspection starts. The inspector calibrates their eyes to these minimum retroreflectivity values. The memory of the brightness of these markings will serve as a benchmark for comparison during the inspections that follow. The calibration markings should include yellow and white and be precisioned to replicate real-world conditions. Calibration can take place while stationary or while moving at highway speeds, as long as the retroreflectivity values in the calibration area are known and are at or above the minimum levels. Calibrating the eyes needs to be conducted under nighttime conditions, just like the inspection itself. When viewing the calibration markings, the inspector focuses about 100 feet in front of the vehicle and commits to memory the appearance or brightness of the calibration markings. For more detail on the calibration process, see the Methods Report. Once out on the inspection route, the inspector compares the markings to their memory of the appearance of the calibration markings to determine if the in-service markings being inspected are brighter, approximately the same, or less bright than the calibration markings. Because the inspector is calibrating his or her eyes to the minimum retroreflectivity threshold, the age of the inspector does not matter. Similarly, since both the calibration procedure and the inspection are done from the inspection vehicle, the type of passenger vehicle is not critical. For the consistent parameters method, the inspector must be age 60 or older. The older inspector can be thought of as a surrogate for maintained minimum retroreflectivity that meets the needs of 90% of drivers, as explained in the Methods Report. Any passenger vehicle is acceptable for this method, but the research that developed the minimum levels indicates that a lower profile passenger vehicle, like a sedan, makes viewing pavement markings more challenging because less light is returned to a driver's eyes. Therefore, a sedan is preferred over a higher profile passenger vehicle like a pickup or SUV. The inspector using the consistent parameters method does not view calibrated markings before inspecting in-service markings. Instead, the inspector documents how well the markings meet his or her needs as a driver to provide an indication of how soon they may need to be replaced. Both methods use inspectors who view the markings during dry conditions at night from a passenger vehicle traveling at highway speeds with headlamps that are properly aligned and set at low beam illumination. While the inspector in both cases will need some type of light for taking notes, it is best to keep interior lighting in the vehicle as similar to normal nighttime driving conditions as feasible. Regardless of the method, inspectors should be trained to understand the important aspects of the specific method they are using. Typically, inspections are conducted using a 2-person crew. While the driver focuses on the driving tasks, the inspector evaluates the pavement markings and records the appropriate information. Elements of proper inspector training include the purpose and objectives of the inspection, the types of markings to evaluate, when to conduct the inspection, documentation, safety equipment, appropriate agency policies, and how to make a judgment on the visibility of the markings. For example, inspectors using the consistent parameters method should know they need to be able to see a marking at least 2 seconds in advance to react appropriately, and understand how this 2-second preview time varies on roads with different speeds. Whereas inspectors using the calibrated markings method should understand why they need to focus their eyes the same distance during the calibration process and the inspection, regardless of the speed. Planning the inspection routes is important for both methods. Minimum retroreflectivity values may be different for higher speeds. Therefore, if the calibrated markings method is being used, plan routes by separating higher speed roads from lower speed roads so the inspector's eyes are calibrated for the correct retroreflectivity threshold for the route. This isn't critical for the consistent parameters method, as long as the inspector is cognizant of speed changes and adjusts his or her focus accordingly when speed limits change. For both nighttime visual inspection methods, the inspection should include multiple passes as needed. Pavement markings that are not immediately adjacent to the inspection vehicle cannot be evaluated during a visual inspection. As an example, a 3-lane roadway would need at least 3 passes. The results of the visual inspections of the in-service markings are used to determine which markings need to be scheduled for replacement. These methods can be used as standalone methods or in combination with other methods to help you maintain your pavement markings. You can find more information about the maintenance methods, pavement marking retroreflectivity, and nighttime visibility at the links posted below this video or at the FHWA Nighttime Visibility website, www.fhwa.dot.gov/retro.